So here we are going to just read the top part, sorting algorithms. What is the problem statement? Given in, yeah, maybe Cassandra, why don't you read the problem statement?
Okay.
Make sure we all understand it.
So starting from the top.
Yeah.
Sorting algorithms. Given an unordered list, we will now investigate different algorithms to sort the list. You should write your code in the lab 6.2 in the file, sort algorithms. Make sure you look at the tests in the file algorithm test, py, and ensure your code passes all these tests before you submit.
Okay, so let me just pause quickly. One of the things I've done to make it easier for all of you to verify your code is I've given you some test cases, right? Kind of saying at least you should pass these test cases. You should write more tests. You should, if you don't write more tests, you should understand the tests I've written, right? Why is this the right test? Just because I've given you tests, don't just ignore them, okay? But this sorting thing is really a compliment. Remember last time I told you for search that the list is already sorted, right? So now if you have an unordered list, you can use a sort algorithm to sort them. Okay, and then we can use the search which we just wrote. So now how we sort the list. So question is, how do we sort the list? And now let's go to the lab and start writing code, right? So first we'll implement the simplest, I guess, the simplest to explain. I don't know. We'll decide at the end which one is the best. So does anybody have an idea how we should sort a list?
I mean, if it is an integer list, then I think I just read in your article as well, but it's BubbleSort is the one, and you have code name as well as a BubbleSort.
Okay, so, yeah. So I said BubbleSort, but now what is BubbleSort? What's the idea in BubbleSort?
So BubbleSort is like you have a list and you take a list on index 0 and list on index 1. You compare them. If they are the list 0 is greater than list at the value at 1, then you just swap them and you keep.
So can we just write, Ashish? Can we write a small take the test example from the test file? Just take the list from there. Yeah. Let's take that one and just work through the example. Yeah, you don't even need the second list. You just need the first one. When you know the answer when it's sorted, right? It's 1, 3, 5, 7, 9. So how would the BubbleSort proceed?
So the way BubbleSort will go in this case is it will come and say,
just put that triple quote below, Ashish, then everything will stay in comments. The last triple quote. Yeah, good. Now you have space to work. Yeah.
So it will come at like first one, it will compare 3 and 5. 3 and 5 are within the list.
Yeah.
Sorry, 3 is smaller than 5, so there is nothing will be changed. It will remain as it is.
Yeah, so just write it like that. That's the first comparison.
Yeah, let me copy this one so I don't have to
keep
writing.
Yeah.
Then it will go for a second comparison. Second comparison remains same it is. Nothing changed because 5 is 5 and 7.
Yeah.
5 is less than 7. Okay. Goes for the third one. Comes for this search and it says 7 and 1 are where 1 is smaller than 7. So it will change this to 1 and then it will make this one as a 7. Then it will go for a one more time and it will say, okay, 1 and
9.
Sorry, 7 and 9 are equal. Oh, sorry. 1 and it will compare. No, it will
no. It keeps going to the right. 7 and 9 are in the right position. Nothing happens.
So nothing will happen.
Okay. So you see, we make one pass, right? From left to right and compare every item.
Yeah.
What it does is it moves things around. In the first pass, do you think any guy has reached his final destination? Has reached the final index it needs to be? Can you see? Has anybody reached a final location?
Yeah, last two numbers are on the list.
So all we can guarantee is it's the last number.
Yeah.
Right? The last number can get, but you can look for patterns. I may not even see it visualized well, but the idea is that it's called BubbleSort because it's like the numbers are bubbling towards their location, right? They're getting swapped, and in certain ways you can visualize them as if the number is moving towards its location. So what is nice about this algorithm is it's just basically the idea is simple: compare and swap if necessary. Okay, but we are not done by just saying compare and swap. Why? Because he made one pass through the list. Is the list sorted? No. So what do we do now?
We need a second pass. Then.
Second pass. Okay. And then wait, and we'll write one more pass. Let's write one more pass quickly.
So in one more pass, it's this one, nothing happens. This one, Oops, sorry, my bad. This is our current list.
Yeah.
So this is nothing happens. First time because it's 3 and 5. Second time is going to be
5 and 1.
and 1. Yep.
Yeah.
And then it's gonna.
Third time 5 and 7. Nothing happens. 5, 7,
nothing
9.
happens,
So nothing.
Nothing
Yes.
happens.
Yes. So you have to keep on. Okay. So if you do this, do we stop now? So when do we stop? How many times do we do this?
You just need one more pass.
No, but in general, if you have a general list, how many times do you think we have to do this?
It depends.
It depends.
How about we divide like binary search and divide into half, and if left value is greater than the right value, or sorry, smaller than the right value, then we are okay. But that
So this is going to be a new algorithm. So Ashish, you're going to work on it, okay? But for today, I'm going to take you down a certain path, okay? But we'll finish off. I'll show you a couple of interesting ones. There are many interesting ideas here, but I'm going to show. So the idea here is, if you do this, so each pass is n comparisons, isn't it? Whatever.
Yeah.
Yeah. Up order n comparisons, right? So I keep another counter, and then I repeat this loop another n times. I repeat this action n more times. Okay, so it's a double nested loop that's going to sort the list. Okay, that's kind of brute force. I have not optimized or anything. So let's try that code out. See how it. Let's start to write this code now. So I'm going to say it's first. Let's write the inner loop. So just loop through the list once. So for I in. Oh, you can do enumerate, you can do range, whatever you want. We really need the index though. We need the index and the value. Actually, okay, I wrote this code using do that for index value, okay. And then a colon at the end. So now we have to compare. So if the value, okay, so this one, actually, you know what? This code will look compact. Let's write it the way I did it, right? I have to come back and think again. Can you write it using range length L for I?
Okay.
Yeah. Range bracket len list -1. So all of you can see in full glory. Len list, the bracket has to be around the list, Ashish. The -1 has to be outside the bracket. Yeah. So you can see in full glory why range is not fun. You have to always remember to subtract 1. Yeah. Range, len, list. Yeah. And no space between range and bracket, Ashish, just to clean up.
No, sorry.
Okay. Now, now we pull out the values. What are we comparing? I and I plus 1, right? No, yeah. If take the value from the list. List I in list LST bracket index, and you want to compare it. What is our comparison?
Plus 1.
Yeah. Index plus 1, right? With the next one. Yeah. Okay.
Equal to? Why I'm saying equal to here though?
Yeah. You have to say, is it greater, right? Greater than. So just do greater than. If it's equal to, we don't need to swap it, right?
Yeah, that's right.
Yeah. So greater.
So if index is greater than.
Okay, just one. I made a small. Okay, that's fine. Yeah. Yeah. Okay.
So here list index should be assigned into some value, Ashish. list index is equal to k, for example, and then you can, so that you can, that allows swapping. Otherwise,
yeah. So we'll implement. Yes. So I paused for a minute. So what do we have to do if this condition is met? We need to swap two items, right? So here I'm going to show you something very cool in Python. If you want to swap two items, you write them as a comma separated values. Just write the two values, list index, comma, list index plus 1. The two values that you want to swap, and put an equal to, and then swap the order on the right hand side. It's very cool, right?
Yeah.
In one line, yeah. It can hurt your head. But I think it's the closest to our intuition for swapping, right? You take two values in the reverse order and assign them. The fact that Python does it in one line is kind of nice, right? Sorry?
I was saying it's the coolest Python thing I've seen.
Yeah, it's a very cool Python thing, right? Because swap is actually a tricky operation, by the way, right? I mean, I won't get into swap right now, but it is very, very, very elegant. So this is a Python idiom, right? I just want to highlight some few Python idioms. This particular one makes it very, very cool. Because you see, if you don't do it this way, I just want to say, I think Siddharth is thinking of this. If you write this in some other language, you have to make an intermediate value, right? Because if you copy one into the other, you'll erase the value, right? So you have to say like, suppose I want, Ashish, can you write a comma b, right? If I want to take the value of a to b and b to a, if you don't have this syntax, what will you do? You will say, you can't write a equals b. Yeah, something like this, right? Yeah. So you see, that makes your head hurt. You have to store it in some temporary variables and erase the variable or not use it, etc. This is all not involved in Python. Yeah. Swapping can be done in one line. Yeah. So you can delete that, Ashish. I just wanted to show why this is a cool thing. Okay. Okay. So we swapped it. Then what? Then one round is passed, right? So this will do one round of what we want to do. Can we just test it in main? Ashish, just print it out. Return the list at the end of it. Return LST. So can we do the first round that you wrote down by hand? Can we see if it's working?
Okay.
Again, I want to show you guys how to evolve this code when I'm not here or we're not together working on it. Make tests. See what's going on, right? So we don't carry all the load in our head. You let the computer do it and see what happens. What do we expect? You can delete all that. You don't need it if you want. Or you can print, yeah.
Is it a bubbles?
BubbleSort, yeah. You can copy it, yeah. By the way, it's, yeah, and the prefix is SO for sort. SO.BubbleSort. Okay, and put the list that you were working on, Ashish, whatever it was. No, you had some code there, right? You did, yeah, I don't remember the numbers.
Yep.
Yeah, I think so. Yeah, just comment out everything else. Yeah. Yeah, and you can deal, yeah, you can run it. There's some bracket missing, maybe.
Yeah.
Missing a bracket at the end.
Yeah, for the print. Yeah. That's one of the Python problems. It gives the error, in this case, in the wrong place. Okay. There's a colon missing. Yeah. Is that our second line?
Yep.
35179, right? So we've done one pass. Make sense?
Yes.
Okay, now we need to do one more list. It's an outer loop now. So put an outer loop around this. For, and now you have to give it for, I don't know. Well, it's an index. Can we call it J index or something? I don't know. Another index, new index, yeah, something, yeah. In range. I'm going to say len L. Range len L. Okay, colon. So basically this loop is rather silly, right? It's just going to repeat this thing many times. This is going to start at the beginning and repeat again, right? Does everybody see what I just did? The return list has to be tabbed out a little, Ashish. Yeah. Does everybody see? I just put in one more loop.
Yeah.
To repeat this as many times as there are elements in the list. Okay, we can tune this a little bit if you want, but let's run it and see what happens. Is this sorted now?
Yeah, it is.
It's pretty cool, right? Now, what I will leave for you as homework exercises is you should put a lot of print statements in the code and see each time how it's moving. Make sense? Cassandra's like, how the hell did it get sorted?
I think I missed something, but I was just trying to keep up.
Okay.
Why
Okay.
it says J index? Did we add that in just now?
Yeah. Just look at the code. I just added one more loop. See, Cassandra, we started in the list, we did the swaps and we got to the end of the list, right?
Yeah.
I want to start again at the beginning and repeat it. Start again at the beginning and repeat it. How many times I'm going to repeat it? As many times as there are elements in the list.
Okay.
Make sense?
Yes. Okay, so we added a different J index to separate it.
Yes. Now, Ashish, you can do one small thing. Keep the list length small. I'll just show you one trick here. Just put a print statement inside the inner for loop. Yeah. This you should all do by hand. Yeah. Put a print here and just print the. Not every time you swap. Maybe I don't know. You can put it wherever you want. Yeah. Put it right here. Print list. Yeah. Anywhere you can put print list, right? And you can see how the list is changing as you go through this algorithm. So it's whatever Ashish was doing by hand. Yeah, if you run it, this should match Ashish's writing by hand, right? Or your writing by hand. And then you'll see how the list got sorted. Okay. Yeah, it's matching up that way. So you should do this one time. Okay. But now I'm going to go to the glory of this code quickly. Look at this code. What do you think?
I think yeah, we might be paying extra cost for running into the loop, but it's easy to see from the eyes.
Yes, it's easy on the eyes, right? Yeah, little tuning can be done, but I want to show you. See, again, as I told you, these algorithms to sort the list is what, 5 lines, 6 lines? Very powerful, right?
Yeah.
Very powerful. Very powerful. So this algorithm is usually always shown in any algorithm discussion because it's the simplest one. Compare and swap. That's all the idea. Huh? The only extra idea is that you have to keep on doing it until you finish. Okay. And now I'm saying that if you look at, because there's 2 loops, there's an outer loop which goes n times, inner loop which goes n times n is n squared. This is an n squared algorithm. The number of comparisons is actually n squared. Okay, and you can put a counter in there and print out the number of comparisons. But what did we learn about n squared in the beginning? Is it good or what?
It's not good.
It's not good, right? It gets the job done, but it's not good. So we have to try to do better.